Fortunately for you, I'm not going to talk about extra dimensions. And also, my intervention, I think, will be quite different from those of my colleagues and friends in that, A, I have no slides, and it will be also very short, and we'll be mainly focusing and sharing with you my own experience for what has to do with science and art, because I think the topic, one of the topics of these discussions today is the relationship with science and arts, and the arts that very often people think to be, not only there is no relations, but these two things are even conflicting or incompatible. So I would like to share with you my personal experience, not to be too much self-centric, but because I can only talk, of course, of things that I don't know well. So when I was a kid at high school in Italy, I have been studying humanities, mainly humanities in a high school which in Italy is called the Liceo Classico, where you study a lot of literature, art, history of art, Latin, ancient Greek, and philosophy, and I loved all those things. And in parallel, I was studying music at the conservatory, so I was very much art and literature and humanity oriented, say. So often people ask me how it comes that you got into physics. And the reason is that because I was a very curious child. And I used to ask myself a lot of questions. At that time, the World Wide Web did not exist. I open a parenthesis, it was invented at Cern, I close the parenthesis, a bit of advertising for Cern. And so I was asking those questions to adults, teachers, and I didn't find the answer satisfactory. And my questions were about nature. How does nature work at the most fundamental level? And I thought at some point when I was 17, 18 years old, and although my knowledge of physics was very, very limited because the high school I was attending at the time, there was very little physics and zero mathematics. So we didn't have even the tools, the mathematical tools to understand physics. And physics was taught, I remember something like 3 hours a week. And was more at the level of telling a tale. But because we are talking about Einstein and relativity, I remember that there was something that happened when our professor telling us the tale of quantum mechanics was really the level of tales, because we didn't have the mathematical tools to understand quantum mechanics, explained to us one of the milestones of quantum mechanics, and this is the photoelectric effect. When you hit a surface, for instance, a metal with light, that surface will emit electrons. But those electrons are only emitted if the light has a given wavelength. If the wavelength is too small or too big compared to specific wavelength, no electrons are emitted. And nobody could explain that effect until Einstein actually got the right solution and actually got the Nobel Prize for that, not for relativity, but for the photoelectric effect. And I found the explanation of Einstein of the photoelectric effect, which was related to the quantum mechanic interpretation of matter and light, so simple, so you will say in English compelling, so elegant, and again, not elegant. I found it very simple and very elegant, so it has to do a bit with art, that I sort of understood that physics was beautiful, and so my heart, which was very close to art, got immediately fascinated by that. And also that physics could really allow someone to explain how nature works. So I decided to study physics at the university, and it was not a very conscious and solid decision. It was not based on facts. It was based on intuition and right? And immediately after starting studying physics at the university, I realized that this is what I really wanted to do. I immediately could immediately see the strong links between what I was studying and humanities, arts, etc. Perhaps it's because the way physics is taught in Italy is quite theoretical, how to say. In Anglo-Saxon countries, usually it's very practical. You get laboratory classes right from the first years. In Italy, it's much more theoretical, much more mathematical, and this is what really I wanted. Addressing the big question, having the fascination of the fundamental laws of nature, quantum mechanics, quantum field theory, etc. And so I really started to see how close was physics to philosophy, how close was physics not only to answer the question, but also to have this kind of elegant, simple, and beautiful, giving a beautiful picture of reality. So today, after almost 30 years of professional activities as a physicist, in particular as an experimental physicist, I can tell you that the division between humanities, sciences, art is totally fictitious, is just an artifact. First of all, I think that art, literature, humanities, science, they are all part of one thing, knowledge, and they are all the highest expression of human beings as clever beings. They are all motivated, they are all pushed by ingenuity, by creativity. When you paint a painting, I guess, I'm not a painter, I guess you need to have an inspiration, you need to be creative. And the same thing in physics. Physics and great breakthroughs in physics come from ideas, from ingenuity. But also there is more than that. If you look, I know music quite well, much better than painting, so I will make comparison with music. When you analyze some music, in particular classical music I mean not general classicism, so I mean the 18th century or 17th century even, okay? Take Bach, for instance. A Bach cantata, if you look at harmonic analysis of a Bach cantata, it's really a piece of mathematics. It's really following the rules of harmony, which is, of course, again, it's related to the sound, to the physics of sound, in a very, very precise way. But of course, it's not mathematics, just mathematics, dry mathematics, because Bach put on it all his creativity and genius. Okay, but actually, it's extremely, extremely precise and follows the rules very, very, very in a very faithful way. And on the other hand, if you look at the fundamental laws of physics, and I'm talking here about laws of physics in the microscopic world, so the world of elementary particles, the equation that describe this world, which is really the foundations of everything, they are extremely simple, they are extremely elegant, they are really beautiful from the mathematical point of view, and in addition, the laws that describe the dynamics of the interactions actually come from symmetry principle. I cannot develop this theme, but they come from some kind of almost aesthetical principle. So for this reason, I think that I'm very surprised when people ask me how it comes that you moved from music to physics, like if we were talking about something completely decoupled. And this is the reason why many great, the previous slide, not great is not referred to me, it's referred to Leonardo. So some of it was the last slide of what Mario showed. So Leonardo was a okay. They know Leonardo. Don't worry. Leonardo was an engineer. So he was a great scientist, and he was at the same time a great artist. And there are many physicists who are very good in art. Einstein, again, we celebrate Einstein, was an excellent violin player. So my message is you should really try to look at mankind and the human beings, clever beings, which are little tiny pieces in the universe, but at the same time we are so clever, as Mario has shown before, that art, science, humanities, they are all really the highest expression, among the highest expression of what we can produce. It is the highest expression of our brain, creativity, and ingenuity. Thank you.